combining geometric growth and decay. So a recurrence relation of the form v n add 1 equals the common ratio multiplied by vn plus or minus d, where v0 is the starting value, can be used to model situations that involve both geometric and linear growth and decay. In the first question, we're going to write down the first 5 terms of the sequence generated by the recurrence relation of the form. The initial value equaling 5, v n add 1 equals 3 vn subtract 2. So here we're going to model. So we're going to show each term and how it was calculated. So our initial value is 5. We substitute that into the next term. So v1 would equal 3 multiplied by 5 subtract 2. And that would be 13. So 3 5s is 15, subtract 2, 13. Now for the next term, we use 13 like we did before with 5. So 3 13s, then subtract 2, we get 37. For the next term, v3 equals 3 multiplied by 37, then subtract 2. Now we get 109. Then we do the same thing for that fifth term. And now we get 325. Now you can also do this on the class pad. And there are a few ways to do this. One way, you could use the main screen. Just put in 5 on the main screen and go execute. Now, go 3 multiplied by, using the keyboard, answer, subtract 2. Execute. And we're going to do it again. So what we're doing is we've formed an algorithm, and we're just going through each term by pressing execute. Okay, and as you can see, we can just keep going if we like. So edit, clear all. The other way is to use the sequence function. We write down 3 an, which is our equivalent here to vn, subtract 2, and initial value is 5. We go to table, and as you can see, we've got our values here as well. Initial value of 5, all the way down to 325. Okay, so we've got 1, 2, 3, 4 and 5. There are our first 5 terms. Okay, the number of crayfish in a commercial farm after n number of years, Vn, can be modelled using the recurrence relation. V0 equals 7,500. Vn add 1 equals 1.2 Vn subtract 2,500. Use the recurrence relation to determine the number of crayfish in a farm after 4 years. So we're doing what we've done before, which is substituting values in to the recurrence relation. So V0 equals 7,500. Substitute that into the relation, we get 6,500. And we keep following the process. And one more. So 2,132. So the number of crayfish in a farm after 4 years is 2,132. Now all of this can also be done on the class pad, like we did before. Edit, clear all. Now we're going to put in the new recurrence relation So we have 1.2. Our equivalent here is AN. Subtract 2,500. Our initial value being 7,500. Okay, make sure it's ticked and then turn on the table. Okay, and as you can see, we have our initial value of 7,500 and V4 is 2,132. This can also be used to answer the next question. After how many years will there be no crayfish left in the farm? Now let's just see if our table keeps going. Yes, it does. V5 is 58.4, and then as you can see with V6, where n equals 6, there's a negative value. Now with this problem, a negative value would mean that there are no crayfish left. So therefore, the answer would be after 6 years.